Hi everyone, Dr. Vaughn here. We're going to look at some homework problems from section 2.1 just to go over some of the concepts for this week. We won't do them all. You'll have a few to do, but I thought this might be a good opportunity just to look at some of the concepts for discussion for this week. All right, so we're going to start with question 1. This is from section 2.1. So find exact values for sine, cosine, and tangent. The thing you want to remember here is SOHCAHTOA, S-O-H-C-A-H-T-O-A. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's see, sine of theta, here's theta. Sine would be opposite 4 over hypotenuse 5, so 4/5. Okay, just keep on going like this. You'll do all of them. Cosine is adjacent over hypotenuse, that's 3/5. And tangent is going to be opposite over adjacent, so that's going to be 4/3. All right, we're going to skip up to, let's see, we'll try number 5. Okay, write the following function in terms of its cofunction. So assume all angles in which the unknown angle appears are acute angles. So tangent of theta plus 20 . Okay, so the cofunction of tangent is cotangent, and then we take the complement of beta plus 20. So that's 90 minus the quantity beta plus 20. So that's 90 minus beta minus 20, and 90 minus 20 gives me 70. So it's cotangent of 70 minus beta. Let's try one other, just similar one to this. Right, tangent of theta plus 5. So the cofunction is cotangent. We're going to take 90 degrees minus theta plus 5, the quantity. So that's 90 minus theta minus 5. So it's 85 minus theta. All right, next question. We're going to jump up and look at number 10. Tell whether the statement is true or false. Tangent of 46 degrees is bigger than cotangent of 46 degrees. So what I like to do with these is kind of think about what the graphs of these functions looks like. The tangent is the opposite over the hypotenuse. And think about the 45-degree angle. So 45 degrees is where the opposite and the adjacent have exactly the same amount. You know, the rise is equal to the run. So if I increase an angle by just a little bit on the unit circle, what this is actually doing is decreasing the adjacent side and it's increasing the opposite side. So tangent of 46 degrees is going to be slightly bigger than 1, which is the tangent of 45 degrees. Now cotangent, you know, think about this in terms of the cofunctions, right? So the cotangent of 46 degrees would be the same thing as the tangent of 44 degrees, because 44 and 46 add up to be 90. So tangent of 46 degrees is bigger than the tangent of 44 degrees, and the tangent of 44 degrees is equal to the cotangent of 46 degrees. So therefore, this is a true statement. The tangent of 46 degrees is bigger than the cotangent of 46 degrees. All right, and we're going to try one more. We're going to jump up and look at maybe question 15. Find a formula for the area of the figure shown to the right in terms of n. Right, so here we have a 45, 45, 90 triangle. This is one of those, you know, the adjacent side and the opposite side have the same distance, n and n. The hypotenuse here is, you know, square root of n squared plus n squared, or 2n squared. But the area of a triangle is 1/2 base times height. So you could do 1/2 of n times n and get 1/2 of n squared. So 1/2 of n squared is n squared over 2. I'll just use the little fraction tool. In the numerator, I'll write n, and then I'll use the exponent button, n squared over, and then put the 2 on the bottom. And that should be it. All right, well, this has been Dr. Vaughn. Hope that got you at least a little bit of a start on your homework for section 2.1. If this short hit video here was useful to you, let me know, and we can make some more. Talk to you later.